popular for their sweet flavor, variety, and convenience as a snack or breakfast. Their texture and customizable toppings enhance their appeal across cultures and age groups. The industrial-scale donut production process begins by combining the basic ingredients, including flour, water, sugar, baking powder, eggs, and other essential components, using a specialized spiral automated mixer. This ensures a thorough and consistent blending of the dough. The prepared dough is then conveyed via an automated belt system towards the sheeter machine, where it is carefully crafted into flat, uniform layers of dough sheets. To prevent sticking during the folding or rolling processes, a small amount of flour is automatically sprinkled onto the dough's surface. Following this, a specialized brushing mechanism helps distribute the flour evenly while preventing any excess from accumulating. Once the dough has reached the desired level of thickness, it is moved to the stamping section, where it undergoes precise stamping to create the individual donut shapes, making it easier to cut the dough into the final donut forms. The stamped dough layer is transported to a specialized donut cutter, which precisely punches the center of each donut, producing the iconic donut hole. Once the donut centers have been extracted, the remaining dough trimmings are systematically diverted to a dedicated section of the production line. Conveyor belts meticulously transport these excess dough fragments away from the primary cutting zone, ensuring seamless collection while maintaining uninterrupted manufacturing operations. The freshly cut donuts are carefully conveyed to the proofing station via integrated conveyor systems. Throughout this transport process, the donuts are meticulously handled and monitored to preserve their delicate shape and structural integrity. The dough donuts are then automatically positioned into specialized, fenestrated trays to facilitate essential air circulation during the crucial proofing stage. This automated positioning reduces manual labor requirements and ensures a consistent, uniform placement of the donuts within the trays. An automated fryer, equipped with conveyor belts, gently lowers the donuts into hot oil heated to a precise temperature range of 350 to 375 degrees Fahrenheit. The fryer's conveyor system meticulously flips the donuts, making sure even cooking on both sides. Depending on the size and thickness of the donuts, the frying time typically varies from 45 seconds to 90 minutes per side. As the donuts fry, the moisture in the dough creates steam, causing the dough to expand and develop the desired airy, light texture inside the finished product. This automated process, combined with the carefully controlled frying parameters, ensures the consistent production of high-quality donuts. The other way of depositing donuts in oil is through the automated donut depositing process, which utilizes air pressure to push dough from a hopper through specially designed nozzles that shape the donuts before they enter the hot oil for frying. This machine uses air pressure to push dough from a hopper through specially designed nozzles, which are designed to shape the product before it enters the oil. Upon completion of the frying stage, the donuts are cooled down using a cooling conveyor system, which establishes a controlled environment where the donuts gradually reduce in temperature as they proceed along the conveyor belt. Typically, cooling conveyors are designed with perforations that permit the excess oil to drip through and collect in designated receptacles below. This design not only maintains the cleanliness of the conveyor surface, but also ensures that the donuts do not remain in contact with oil during the cooling phase. Following the cooling, a dusting of powdered sugar alternatives is automatically sprinkled on the donuts. This application is intended to create a uniform surface, effectively absorbing any remaining moisture or oil. It also serves to regulate the absorption rate of the subsequent glaze, thus guaranteeing a consistent and even coating. The donuts are then subjected to a continuous glaze application process, wherein the flowing glaze uniformly envelops every surface of the donuts. This uninterrupted flow guarantees comprehensive coverage, providing each donut with a glossy, sweet coating that effectively enhances its taste profile. Excess glaze, which may escape down the sides of the donuts, is efficiently captured by a drip tray positioned beneath the conveyor system, which is then subsequently redirected back into the glazing apparatus, thereby optimizing resource utilization and minimizing waste. The ability to glaze multiple donuts concurrently substantially accelerates the overall production process. Chocolate glaze can also be applied using a chocolate enrobing machine, which operates in tandem with the conveyor belt transporting the donuts. As the donuts traverse a specific segment of this process, the chocolate glaze is administered from below, or alternatively, the donut is entirely encased in the chocolate coating. Once the donuts are glazed, an automated robotic arm equipped with precision-engineered grippers extracts the donuts from the current conveyor belt and transfers them to another conveyor system designed to facilitate their journey to the topping station. During their transit on the conveyor, the donuts advance beneath a topping dispenser, which methodically distributes sprinkles evenly over their entire surface. Liquid vanilla can also be applied as a topping using a specialized machine that meticulously crafts uniform patterns across each donut surface. Complex zigzag formations are frequently made to provide a visual contrast against the rich, dark chocolate glaze, thereby augmenting the aesthetic appeal of the donuts. Following the completion of the glazing operation, the donuts are systematically cooled as they progress along the conveyor belt. Undergoing a final inspection, donuts are transported by conveyor to the automated packaging area, ensuring each meets quality standards. Here, a bagging machine forms plastic bags, fills them with donuts, and seals them to maintain freshness. Packaged donuts are then visually inspected before being grouped into larger boxes, Ready for distribution and delivery. The cooking process for large-scale production begins with automatic mixer machines mixing flour, water, yeast, and other ingredients in precise amounts. This mixture is blended until it forms a smooth dough. Once the dough is ready, it moves along conveyor belts within the factory. These belts transport the dough to different areas where automated systems take over. These systems shape the dough into uniform balls, ready for the next stage of the pizza-making process. After the dough has been prepared and shaped into uniform balls, the process moves on to handling these dough balls in large quantities within the factory, where they are accumulated in large numbers. Automatic machines take over the task of transporting these dough balls to various parts of the factory. This is done using a complex network of conveyor systems and lifts. Some conveyor belts may carry the dough balls to resting areas where they undergo a brief period of fermentation, allowing the dough to rise and develop flavor. Others may transport them directly to the stations for the automatic pressing process. In the first method of shaping pizza bases, the dough balls are subjected to precision pressing mechanisms. Once portioned by the dough divider, these uniform dough balls are carefully transferred to the pressing station. Here, specialized machines descend upon the dough balls with calculated force, gently but firmly pressing them into round pizza bases of consistent thickness. The pressing action ensures that each base maintains uniformity in size and thickness, crucial for the overall quality and appearance of the final product. Alternatively, the dough can be shaped into elongated sheets, ready to undergo a different method of transformation. In this approach, the dough is fed through a series of rolling and cutting machines, each meticulously calibrated for precision. As the dough sheets advance along the production line, rotating pressuring machines descend upon them, exerting controlled pressure to cut the dough into the desired shape of pizza bases. The rhythmic motion of these machines ensures that the dough is uniformly shaped and sized, maintaining consistency across the entire batch. This method offers an efficient alternative to shaping individual dough balls, allowing for high-volume production while upholding the same standards of quality and uniformity. By employing this technique, automated factories achieve optimal efficiency without compromising on the integrity of the final product, ensuring that each pizza base is perfectly primed for the toppings and subsequent stages of production. Once the dough is prepared and round, the automated process transitions into the pizza topping phase, where advanced technology first dispenses precise amounts of tomato sauce onto each dough round, ensuring an even coating across the surface. These sauces are carefully spread and distributed using specialized rolling machines, ensuring thorough coverage and uniformity on every pizza base. Next in line are the mixed toppings, ranging from savory meats to fresh vegetables. Machines equipped with rotating arms delicately dispense these toppings onto the sauced bases. Each ingredient is measured and distributed with precision to maintain consistency across the production line, ensuring that every pizza receives the perfect balance of toppings. Finally, comes the shredded cheese topping, a hallmark of traditional pizza. Specially designed machines evenly sprinkle a generous layer of shredded cheese atop the assembled pizzas, ensuring that every bite is filled with gooey, melty goodness. These machines are calibrated to dispense the precise amount of cheese needed for each pizza, guaranteeing uniform coverage and optimal flavor distribution. For long-term storage or distribution to distant locations, pizzas undergo a freezing process. This typically involves placing the packaged pizzas in a blast freezer or tunnel freezer, where they are rapidly cooled to freezing temperatures. Freezing helps extend the shelf life of the pizzas and preserves their quality during transportation and storage. Most frozen pizzas are not pre-cooked, although there are a few exceptions to this general rule. In this case, the pizzas are moved into large ovens for cooking. These ovens can be conveyor belt-style ovens where pizzas move through on a continuous belt. Frozen pizzas are transferred onto conveyor belts that transport them to the packaging area. Systems are equipped with sensors and controls to ensure smooth and continuous movement of the pizzas. The pies are automatically fed into wrapping machines. These machines use a combination of rollers, heat sealing mechanisms, and cutting devices to wrap each pizza in plastic film or shrink wrap. The plastic film is dispensed from rolls and securely sealed around the pizza to protect it from external contaminants and maintain freshness. For pizzas packaged in cardboard boxes or cartons, automated carton erecting machines are employed. These machines can quickly assemble flat cardboard blanks into fully formed boxes with precision. Sealing machines securely close and seal the cartons using adhesive tape or hot melt glue. These machines ensure that the cartons are properly sealed to prevent tampering and protect the pizzas during transportation and storage. If you're really curious about how more types of food is made using cool technology and stuff like that, then get ready to